Hello students, today I am going to discuss how to find the pole of the plane with respect to the sphere. Okay, so coming to the problem, find the pole of the plane x minus y plus 5z minus 3 is equal to 0 with respect to the sphere x square plus y square plus z square is equal to 9. Okay, so this is very important problem for short answers, right? So we have to find the pole of the plane with respect to the sphere. So listen carefully. So the given plane equation is, so the given plane is x minus y plus 5z minus 3 is equal to 0. So treat this as 1, equation 1. Okay. So we have to find the pole. The pole is nothing but it is a point. Okay. So that is why I am supposing let P x1 comma y1 comma z1 be the pole of equation 1 with respect to the sphere x square plus y square plus z square minus 9 is equal to 0. So this is 2. Okay. So now we have to find this particular point x1, y1 and z1. Right. So whenever you suppose that P is a pole of 1 with respect to the sphere, then we can find the polar plane. Okay. So whenever we are having a point together with a sphere, then we can find polar plane. In our previous class, we have done a problem in that model. Okay, so that I am finding the polar plane. Therefore, polar plane of P is the point, the pole. The polar plane of the point P x1 comma y1 comma z1 with respect to the sphere, x square plus y square plus z square minus 9 is equal to 0 is s1 is equal to 0. Yes, this is the formula for the polar plane. Okay, so now we have to write s1. Here s1 is nothing but, so x square can be written as x into x1, y square can be written as y into y1, and z square can be written as z into z1 minus 9 is equal to 0. So this is s1. So now we have to substitute the point x1 y1 z1 in x1 y1 z1. So once again we get x1 plus y1 plus z1 minus 9 is equal to 0. So if you observe this equation, here x1 y1 z1 is a point. It means that is a constant. So x y z. So it means this is a plane equation. So here what we have written is this is the polar plane. Okay, it means equation 3 represents a plane equation. Already we are having a one plane equation, that is x minus y plus 5z minus 3 is equal to 0. It means we are having two plane equations. So that I am writing since 1 and 3, equation 1 and equation 3 represents the same planes, the same polar planes. Why? Because I am saying that both are polar planes. So this equation 3 is just now we find with the help of s1 is equal to 0. Already it was given that on the plane equation x minus y plus 5z minus 3 is equal to 0. That plane is nothing but a polar plane. Why? Because we are finding the pole of that plane, so that we call that plane as a polar plane. It means we have already given a polar plane, But once again, we have find another polar plane with the help of the point P. So that I am writing equation 1 and equation 3 represents the same polar plane. So then I am equating the coefficients of 1 and 3. So how can I equate this? So from the third equation, the coefficient of x is x1, and from the first equation, the coefficient of x is 1. So that we have to write in this way: x1 by 1 is equal to. Similarly, the coefficient of y in the third equation is y1, and the coefficient of y in the first equation is -1. So that we have to write -1 is equal to. Similarly, the coefficient of z in third equation is z1 by the coefficient of z in the first equation is 5. Okay. After that, you also equate the constant terms from both the equations. So the constant term in the third equation is -9, and the constant term in the first equation is -3. Okay. After equating all these terms, now we have to equate all these equal to t. Okay, say. So we are equating all these terms to the constant t. I am equating it to t. So now from this we can write x1 by 1 is equal to t, and y1 by -1 is equal to t, and z1 by 5 is equal to t. And also we can write -9 by -3 is equal to t. Okay. So from this we can write x1 is equal to t, y1 is equal to -t, z1 is equal to 5t. And from this we can write t is equal to 3. Okay. So after getting t value, we have to substitute the t value in x1, y1, z1. So here x1, y1, z1 is nothing but that our pole, required pole. So therefore, pole t is equal to what we have written is x1 comma y1 comma z1. So in this we have to write x1 is t comma -t comma 5d. And in this we have to substitute the value of t, which is 3, in place of t. So that we get 3 comma -3 comma 5 3s are 15. So therefore 3 comma -3 comma 15 is the pole of equation 1 with respect to 2, means with respect to the given sphere. So in this way we have to find the pole of the plane with respect to the sphere. Okay. So once again, I'm going to explain you one more problem. So write on the next problem. Here also we have to find the pole of the plane. So one more problem. Find the pole of plane x minus y minus z plus 9 is equal to 0 with respect to the sphere. With respect to the sphere, x square plus y square plus z square minus 2x plus 4y minus 6z plus 5 is equal to 0. Okay. So one more problem on pole. Right. So first of all, we have to write the given plane equation. So given plane is x minus y minus z plus 9 is equal to 0. So treat this as equation 1. So now we have to suppose the pole that p x1 comma y1 comma z1 be the pole of equation 1 with respect to the sphere x square plus y square plus z square minus 2x plus 4y minus 6z plus 5 is equal to 0. So treat this as equation number 2. Okay. So whenever we are supposing that P is a pole of equation 1, then we can write the polar plane. Okay, with respect to the sphere. So that I am writing, therefore, polar plane of P is equal to x1 comma y1 comma z1 y1 comma z1 with respect to the sphere to equation 2 is s1 is equal to 0. So we know how to write s1. So I am writing that x square can be written as x into x1, y square as y into y1, and z square as z into z1. And minus dx can be written as minus of x plus x1, and 4y can be written as 2 into y plus y1, and minus 6z can be written as minus 3 into z plus z1 plus 5 is equal to 0. So treat this as equation number 3. So this equation represents a plane. So if we have to modify this equation, so then we get, if we take x common, we get x1 minus 1. And if we take y common, we get y1 plus 2. And if you take z common, we get z1 minus 3. Okay. So this is x term, this is y term, then this is z term. So whatever the terms remaining in the above equation, the third equation, those are all constants. Okay. So that I am writing the constants, and those are we still having minus x1, next plus 2y1, next minus 3z1, and finally plus 5. The remaining terms are these terms is equal to 0. Okay. So I'm still writing. So don't treat this as equation 3. So once again I'm writing this in a simple way. X into x1 minus 1 plus y into y1 plus 2 plus z into z1 minus 3. And I'm taking minus common from all these terms. x1 minus 2y1 plus 3z1 minus 5 is equal to 0. So now treat this as equation number 3. Okay, this also represents a plane equation. So of course polar plane, but we are already given a polar plane. Okay, equation 1 represents a polar plane. So therefore I am writing, since equation 1 and equation 3 represents the same polar plane. So represent the same polar plane. So this implies now I can equate the coefficients. So from third equation we are having the coefficient of x is x1 minus 1 by, and from the first equation we are having 1. Similarly, we can write y1 plus 2. This is the coefficient of y from third equation by minus 1. That is the coefficient of y in the first equation is equal to z1 minus 3 by. So we are having minus 1 as the z coefficient in equation 1. And finally coming to the constants, we have to write minus of x1 minus 2y1 plus 3z1 minus 5 by the coefficient in the constant term is, sorry, the constant term in the equation 1 is 9. Okay. So we have to equate all these terms to a constant small p. Same. So from this equation, we can write x1 minus 1 by 1 is equal to 3. y1 plus 2 by minus 1 is equal to 3. z1 minus 3 by minus 1 is equal to 3. And the minus of x1 minus 2y1 plus 3z1 minus 5 by 9 is equal to 3. Okay. So From this we get x1 is equal to t plus 1. And from this we can write y1 is equal to minus t minus 2. And from this we can write that 1 is equal to minus t plus 3. And from this equation we get minus x1 plus 2y1 minus 3z1 plus 5 is equal to 90. Okay, so these are all the terms we are having. So now therefore the point P is equal to x1 comma y1 comma z1. So this is the point P, but we have to find the value of T also. It means we have to substitute the value of x1 y1 z1 in 90 value. Okay, so that I am doing that. So we have 90 is equal to minus x1 plus 2y1 minus 3z1 plus 5. So this is the value of 90. So in this equation, we have to substitute the values of x1, y1 and z1. So we are having in terms of t. So we have to substitute those particular values in the value of 90. So that I am substituting. So minus x1 is minus t minus 1. Since x1 is t plus 1, we have to multiply it with minus 1. So that we get minus t minus 1. So plus 2y1. So we have to multiply the value of y1 with 2. So that we get 2 into minus t minus 2. And the value of z with minus 3. Minus t plus 3 and plus 5. So on simplification, minus t minus 1 minus 2t minus 4 plus 3t minus 9 plus 5. So this is equal to, on simplifying t terms, we get this gets cancelled, minus 3t plus 3t gets cancelled. So minus 4 minus 1 minus 5 plus 5 gets cancelled, and finally we get minus 9. Okay, so on LHS we are having 90 is equal to minus 10, so the t is equal to minus 1. So after getting t value, so then we can write the point t x1 y1 z1. So therefore t is equal to x1 comma y1 comma z1 is equal to t plus 1 comma minus t minus 2 comma minus t plus 3. So in this point we have to substitute the value of t minus 1. So that we get minus 1 plus 1 0. So minus of minus means plus 1. 1 minus 2 is minus 1. Minus of minus plus 1. 1 plus 3 is 4. So therefore t is equal to 0 comma minus 1 comma 4 is the pole of 1 with respect to the sphere 2. So in this way we can find the pole of the equation, pole of the plane equation with respect to the sphere. Okay, so I am giving you one more problem on this model. So you have to solve this and find the solution, find the pole. Okay, and the problem is find the pole of the plane 10x minus 2y minus 5z minus 2 is equal to 0 with respect to the sphere x square plus y square plus z square minus 6x plus 2y minus 3z plus 1 is equal to 0. Okay, right. Thank you.